Okay, great. So it's now recording. I've only gone over one slide so far, so students watching this later are not missing much. All right, so from your reading, what is a variable, or what is an example of a variable? You can either type it out in the meeting chat or raise your hand. Either way is great. Yeah, anything that changes. Very good. So yeah, anything that can change. So is there any examples you have of something that can change that you might measure as we're studying psychology? A reaction, yeah, to flavors of ice cream, any kind of behavior. Good. So you could look for behaviors of excitement. You could look for behaviors of anger or uncomfortableness. I don't think that's a word, but that's all right. Reactions to things like weather you could study as well, weather changes as well. Yeah, so anything and almost everything could be studied as a variable. Here on the slide, we've got emotions, maybe anger or sadness and happiness. You can measure those. You can measure and watch behaviors that are changing here with the ice cream and social behaviors. Another variable is temperature. So you could measure how temperature affects people's behavior. So if it's hotter, you're probably more likely to see the behavior of getting ice cream from an ice cream truck or stand more often than if it was frozen outside. Luckily, that's not the case yet in this semester. So essentially anything that can change, and these are things that a researcher can measure. These are things that they want to measure. They want to measure happiness. They want to be able to either measure or even manipulate temperature. So if you've got a laboratory and you want to see if heat makes people mad, you might take one room and keep it maybe a normal room temperature, and the other room you heat up to say 85 degrees or maybe even 90, see if people have more aggressive behaviors in that kind of case. So these are examples of variables. So it's just a specific word for anything that can change and that the researcher is measuring. So another important thing to understand when we're talking about science is the idea of a theory. And so a lot of people, lay people, just generally use the word theory incorrectly. So you might have heard people say, oh, that's just a theory, as a way to change an argument or turn in an argument in their favor. That really doesn't show a very good understanding of how scientists use the word theory. So that is really common as people talk about it. But the way people are saying, oh, that's just a theory, often is a little more similar to how scientists use the word hypothesis, which is maybe just one testable idea. A theory, on the other hand, is a really broad idea or set of ideas. So a whole bunch of things that can explain and predict observations. So it's kind of a nebulous way to describe it, but I hope with some examples that'll be a lot more clear. So some kind of broad idea or set of ideas. So more than just one thing that explains things like, say, gravity, for example. So a really important piece of theories is that they should be falsifiable. If it's a good theory, you should be able to be, it should be able to be proved false. So you can't write a theory and then keep changing it around. This is one thing that Freud is often criticized for. So, for example, part of his theory was that a lot of human behavior is tied to psychosexual urges. And so he described and wrote about smoking as being an oral fixation, that you never lost that oral fixation from childhood. It started way back then and you just never lost it. But then other people pointed out in the future that he enjoyed smoking cigars. So does that mean that Freud had an oral fixation? And as one example of this, he said, oh, well, sometimes it doesn't mean that you have an oral fixation. He kind of changed and moved the theory around. So you have to be able to prove your theory false. It needs to be falsifiable. Obviously, you don't necessarily want your theory proved false if it's something that you're working with and you've kind of come to or come up with, but it needs to be able to have evidence show that it's wrong if it is truly wrong. So let's use some examples of a theory that was falsified. So this broad set of ideas of spontaneous generation was a theory that was popular for many, many hundreds of thousands of years. Essentially, the idea of spontaneous generation was that all matter comes from other matter, and that it doesn't necessarily have to go through any kind of process. Well, I'll give some examples here. So Aristotle thought that matter was simply generated spontaneously from other nearby matter. So it was spontaneous generation. And this was an idea that a lot of people had before and after Aristotle's time. So if he looked at the observations he could see, you had a silo full of grain, and suddenly one day you go out there and there's mice or rats. So the idea was that that matter of that grain was generating these rats. So it was also things like dead wood was spawning or becoming mushrooms. So on ships also they saw grain, and then all of a sudden mice appeared. And so we can think about that now, knowing that spontaneous generation doesn't really happen. And we realize, well, there were probably a couple mice, they were eating, they were having baby mice. So now there's lots more mice and you're observing them, that kind of thing. But it was a very popular theory for a very long time, even up to very recently. So that's the idea. Spontaneous generation is a broad set of ideas that explained how mice appeared, how mushrooms appeared, how lots of different aspects of the world worked. So with that, if there's any questions as I'm going through, feel free to raise your hand or make a comment in the notes. So that's the broad idea or set of ideas that explained the generation or the appearance of things like mice. So again, theory is that broad set of ideas. It needs to be able to be proved false. So what's one way you could test and prove that that is false? Well, you would have to show evidence that some life came not from generating from some other object, that this life did not come, was not spawned from dead wood, or maggots didn't spawn from rotten meat. You'd have to show that somehow in a controlled environment. So one of the first ways this was falsified was in 1668. So the experimenter put meat, just rotting meat, in 2 jars. One was sealed, over here is an example of that, 2A, and one was not sealed. As you might imagine with your own knowledge, the one that was not sealed fairly soon got some bacteria on it, had some maggots, had some flies flying around. The jar that was sealed in a controlled environment did not have that life growing from it. So it showed, it was one example that life seemed to maybe spontaneously generate here, but there must be something else going on because you have that same bit of meat here in a sealed environment, but no generation of life. So that's an example. That's one piece of evidence that suggests that this theory might be false. So people still believed it for quite a long time. So the last kind of nail in the coffin of the theory of spontaneous generation happened in 1859. Oh, and these slides on spontaneous generation are the things that are not in these slides that you may have downloaded. But I'll re-upload these slides, so if you download them again, all these pieces will be in there. So in 1859, Louis Pasteur took some boiled meat broth and put one in this kind of swan neck flask. Well, did 2, did essentially the same experiment just with broth. And so one of these, he left the flask lid on or just left it open to the air. And the other one he sealed. So first he boiled that so that none of the bacteria existed. So any living thing, they assumed any living thing would be gone from that place because the meat broth was boiled. So it shouldn't get any diseases unless it was maybe spontaneously generated. But they sealed one and nothing spontaneously generated. So that was seen by many as kind of the final nail in the coffin. There were some holdouts, though. After Pasteur did that, other researchers tried to replicate that. And replication means they tried to do the same experiment to see if they achieved the same results. And many of them found that even in their sealed container, life started to appear. There was bacteria, there was other things that were living. And so one thing that they realized over time was that those other researchers hadn't sterilized their equipment well enough. And that was really some of the beginning of the field of microbiology, realizing that there's these very, very tiny organisms that we can't see. Some of them can survive being boiled. And so it still took a little while for everybody to come on board that spontaneous generation wasn't a thing. And in the midst of those experiments between 1668 and 1859, there were many others who did similar kinds of experiments to show that spontaneous generation did not adequately explain the observations that we see in life, falsifying it, showing evidence that would suggest that spontaneous generation was false. So it took a long time. This really shows that any theory tends to hold for a while. It needs a lot of evidence to falsify it to then move on to the new theory. So with that, it's especially hard when you have less control over variables. So in the case of spontaneous generation, in the past, in 1668, they didn't know a lot about microorganisms at all. And so they didn't have as controlled environments. So this container here, 2A, that's sealed, there might still have been life in it when it was sealed, right? So that might show data that might suggest that it did spontaneously generate. So other microbes were not sterilized by Pasteur. When he replicated his own studies, he found different results some of the time because there were microbes that were not killed in the boiling process. So this does show that that theory, that broad set of ideas that, for example, that matter comes from other matter, took a while to falsify, to show that it's false. And that's kind of the process that theories go through. You have this theory that you're working from. A scientist might say, well, I don't think that adequately explains it because if you do this experiment up here or this experiment down here, you don't get the results that you would expect from that. But it takes many of those kinds of times or a couple of those times to show and really falsify a theory. So let's jump to psychology. Let's talk about a theory in psychology that we're still using today. So Vygotsky's sociocultural theory is kind of a broader theory than we're going to cover right this second. But basically, it talks about how people learn and emphasizes their social and their cultural experiences as one way that they learn and develop through life. So one specific thing that we'll focus on right now is the zone of proximal development. And so this is a model of the zone of proximal development. Essentially right here are things that you can currently do. So I'll use my wife as an example. She can probably hear me. Hopefully she doesn't get mad at me. She's trying to learn how to play the ukulele. So what can she do? She can play a couple chords. She can play a couple notes. She's starting to be able to understand as she reads music. So what can she do with help? Well, she has an app that teaches her other chords, other notes, things like that. So with that app, she's able to play more complex songs than she was able to play yesterday. What she can't do is play some of her favorite songs that she's wanting to work up to. Right, so that is how that zone of proximal development is still a very strong part of Vygotsky's theory that we still hold on to today. It's used a lot in education, in training people. So there's this idea that you can do these things with the help of your social and cultural experiences. You might be able to do a little more with that direct support. And then even with that, you can't do some things. As you're learning, there's still some things that are out of your reach. So with that being said, how might you try to falsify this theory? If the theory is saying that you have to learn through experience, through support from other people, through developing that over time, what kinds of thing would show that this is not true? What kind of evidence would you need to show that this is not the case? When you have an idea, feel free to raise your hand and then take over with your microphone. Go ahead, Richard.
Maybe kids or somebody that are like considered prodigies that potentially just do stuff because they have it innately, potentially.
Yeah, that's a really good example. If you saw a lot of evidence of many children who didn't ever seem to get help or have exposure to, say, music or playing the ukulele, let's say someone's never seen an instrument, heard music before, but all of a sudden they pick up a ukulele and can play some really complex thing, that might be one piece of evidence that would suggest that this is not the case. Good. Any other examples? So I see Don made a comment, someone who has practiced multiple hours with instruction. So that would be an example that would be supportive of this theory, that if you can do something, let's say you've just started ukulele and then you're getting some instruction and you're practicing many hours, that would fit into this example, this theory, for example. But someone who just seems to already know this, how to play a ukulele, that would be a piece of evidence that would suggest that this doesn't always hold true. Another example is if we had something similar to The Matrix, or I've been watching Smallville recently, and I don't know if anyone's ever seen that, but Superman gets transported to the Fortress of Solitude and gets a bunch of knowledge beamed into his head. So if we saw someone just suddenly one day be able to do and know things without having learned, without someone. Oh, that's a good, okay, Don, good point. I'll actually come to that in a second. So if we saw another person who just suddenly one day they knew how to do things without having any experience in the past, that would be a good suggestion that maybe this zone of proximal development is not how we learn. So Don made a clarification to the comment that I think is really interesting. So someone who's practiced for multiple hours with instruction, but they cannot do the thing afterward. So they can do something, but they're getting help, but they're still not developing that skill. That might suggest that maybe we do, as humans, need to learn a different way than this. So if we saw a lot of evidence of, say, prodigies or people just suddenly being able to do things, or even being taught directly and not learning, those kind of pieces of evidence might falsify this theory. So hopefully that gives you some ideas of what we would do in psychology to try and falsify this theory, or if we were seeing a lot of observations, a ton of prodigies are suddenly appearing, and that's a lot more common than it is, and we can really not point to anything like they had exposure here, or they learned here, or they read about it. It's not associated with any of their other skills. We might have to think about, well, should we modify this theory or should we throw it out? And do we need to come up with a new theory of human learning? So really great examples. All right, so again, a theory like sociocultural theory, like that theory of spontaneous generation, is this really broad set of ideas that is explaining and predicting observations. And I really want you to remember that they should be falsifiable. You should be able to find evidence or make tests and test these theories in ways that they could be proved false. All right, so a hypothesis specifically is one single testable idea or prediction. They're generally derived from a theory, but it's one more simple testable thing. As an example, I was reading a paper today where the authors were trying to make a new survey of a new kind of construct that they felt was related to social identity, but they thought it was slightly distinct. And so from theory that they had read, they said, well, social identity means this, but you might have group identity that's similar, but isn't your entire social identity. So this is how those two are distinct. So as a hypothesis, they said, well, we're going to test and ask people questions and see if they fit more with our idea of group identity or if they fit more with the idea of social identity more generally. So that was their hypothesis, that they would find evidence for one or the other. So it was a lot smaller than a big general theory. It all fell under this idea of identity. The bigger theory was identity and social identity, but they thought there was a smaller component of that group identity within that social identity. Maybe not a great example. So with that, though, as more and more hypotheses around a theory are supported or turn out to be true, that theory does gain credibility. So when we saw that first test in, I think it was 1668, that suggested that spontaneous generation was not, oh, is Richard's hand still raised?
No, sorry, I accidentally left it up.
Okay, I thought that was what was going on. But thank you very much, Don, for calling my attention to that. I appreciate it. So yeah, as more and more hypotheses that a theory that you make based off of a theory turn out to be supported, it gives the theory more credibility. So if we see that one time that the jar with the meat gets maggots and the one that's sealed does not, if we see that one time, we might not jump to this brand new theory, right? We might have to see that multiple times. We might have to have that tested multiple ways. We might have some people that tested it and it doesn't come out the right way. Maybe they didn't sterilize their equipment well enough. So it takes multiple times of seeing these hypotheses turn out supported, and then that theory gains credibility, and eventually people say, okay, yep, this new theory does explain things a lot better than the old. So that's the process scientists use to move from one theory to another. Any individual study is generally testing one or more hypotheses. So here I might, using the zone of proximal development, I might hypothesize that a 3-year-old can learn basic math with support. That I wouldn't expect a 3-year-old who's never been exposed to math at all to be able to do math, addition, subtraction, maybe some basic algebra. But if I support them, if I help them, if I teach them the numbers, what the symbols mean, addition, the plus sign, the minus sign, the equal sign, if I support them and help them with that, eventually they should be able to learn math. And that's what that theory suggests. So we can test that. We can see, is that how it happens? Or maybe if we just give another 3-year-old, maybe another 53-year-olds just math books, see if they come up with the answers or if they've just scribbled in them afterwards. That would be maybe one way we could do an experiment. Take 50 children, give them one-on-one instruction, give another 50 children the same math books, and see who comes up with more correct answers after being taught math for a week versus probably scribbling in their math books. So empirical testing of the hypothesis is really important. So doing that kind of thing like that experiment. So yeah, I gave the Freud example. I think that's useful enough right there. So for empirical testing, the things that you need to do empirical testing are operational definitions. So you need to define exactly what it is that you're measuring, that you want to test. You want to define essentially what your variables are. You want an operational definition of your variable to make it clear to other scientists what it is you're actually looking for, what are you wanting to observe. So in that paper I described briefly earlier, where they're talking about social identity versus group identity, they had essentially a paragraph for each of those describing exactly what they mean by social identity, citing multiple papers. This paper talked about social identity. This is what social identity is. And then a whole paragraph, well, more than that really, describing what they thought group identity was, how it was different than social identity, and how it might be related to social identity. So that was their operational definition. You need to have some data and then analyze that. So that might be through observations. You observe children and their parents. You have survey results. You know the test scores of the children on that math test. So with that, how would we operationalize happiness? How would we describe that variable in a way, tell people how we're going to measure it? Or how might we measure happiness might be a better way to phrase that question. Yeah, that's one good example. And what a lot of psychologists do is have subjects report on a scale. So they report about themselves on how happy they are. Maybe they have just those faces from sad to happy and circle one or something like that. Good example. Any other ways you might measure happiness? Maybe if you're just observing people, how might you decide that one person's happy versus one person's not? Yeah, definitely looking for emotion, but how specifically would you say something is, say, happiness versus excitement, or both? And then specifically, what kind of behaviors? Yeah, time they spend smiling would be great. A tone of voice could be good. Some people have different faces that might, like different muscle structures that they kind of look like they're frowning a little more often. So you might have to worry about that. If you don't know someone's general tone of voice and they're really monotone, you might think that they're not happy when they really are. Yeah, these are all really good ideas. Any other ideas for how to operationalize happiness? Yeah, gestures, so behaviors like that. Yeah, crying would probably suggest, depending on other context clues, that maybe they are or are not happy, how they hold themselves in body language. Yeah. And one really good way to get at happiness would be to add all of these things together, if you could, in a study. To measure happiness by measuring these kinds of behavior, their tone of voice, their gestures, their body language, and also have them self-report. If you get multiple measures of one thing, you're going to have a better chance of getting an accurate measure of that variable. So going here over to the slides, here's a couple ways we might measure happiness. So this is not a very valid way if you just try to measure someone's smile. So some people have wider mouths, some people have less wide mouths. So not a great way to measure happiness, but you could try that, right? It is still giving you data, just maybe not as valid. You might take a swab, say a skin swab or a blood sample. From that, you can actually test things like hormone levels that someone has and different chemicals in their blood to see if those chemicals are associated with happiness versus not. You could give them a self-report scale like this with words on it. You might have seen one similar to this in, say, a doctor's office when they ask you, how much pain are you feeling? Yeah, that's another good one, Don, brain activity. So you can hook them up to a different kind of machine, whether it be an MRI or just looking at an EEG, and see what parts of their brain are activated to see if they're happy. So very good. Lots of good ideas. So there are lots of ways we could operationalize happiness. There's lots of ways we could operationalize a lot of different variables. Some of them are obviously better than others. So even though we're getting data here with this measuring of the face, it's not going to be as useful of data as if we did, say, a self-report scale, or we maybe checked brain activity as well as got hormone level and had them do a self-report scale. So there's ways to get better data and worse data, medium. So you want the best you can, though. Another thing you'll do after you get that data is test it. Use statistics. So you test your hypotheses and analyze these statistics. Let's say this is your graph of people's happiness. There's a few people you thought were very, very excited. Or maybe what you did was measure their smiles. A few people had really, really wide smiles. A few people had really small smiles. And most people had somewhere in the middle. So, or you might check hormone levels. Very few people had very many, let's say, oxytocin. You could check oxytocin in their blood. Actually, I think that one's the chemical more associated with love. But still, same kind of idea. And you would look for things like this. If you give them ice cream, is that related to them being more happy? You could check scales. You could check hormone levels, brain activity. So you would look for things like correlations or look for averages. Compare the numbers to other groups. So you do an experiment. Put 50 college students in a room with coffee versus 50 college students in a room with ice cream. See who has more happiness. That's a toss-up, I think. I don't know. I mean, really, I'd probably be most happy jumping through both rooms. But I mean, then I would just be the researcher and I'd be able to do that, get the ice cream and the coffee. Maybe that's why I went into research. No, a key point of inferential statistics is trying to also falsify hypotheses. So that theory is that really big, broad set of ideas. This hypothesis is a smaller one single testable thing. So my hypothesis in the coffee versus ice cream example might be that ice cream will make people more happy than coffee. So I do that test. I give a bunch of people coffee. I give a bunch of people ice cream. I give a bunch of people nothing. I have them do a self-report measure to say how happy they are at the end of, say, the 5 minutes in the room with nothing, coffee versus ice cream. And then I check those things. I check and see, well, is it actually the group with the coffee that's the most happy? That would then falsify my hypothesis, show that, well, it wasn't actually in this sample, the people who had the coffee were the most happy. But if I did that same experiment on, say, a 5-year-old group, probably wouldn't want to give 5-year-olds coffee, but just as an example, I would suspect the 5-year-olds wouldn't like the coffee very much, and they would be much more excited about the ice cream. So in the college students, maybe we would see that the ice cream is not actually the thing that makes them the most happy. Maybe it's the coffee. Versus the 5-year-olds, we might see that the ice cream is more exciting. So you can see even with one single test that might falsify that hypothesis in a group of college students, that hypothesis still might hold true in, say, other groups, or other groups might behave differently. So based on age, based on culture, based on gender, a whole bunch of different variables. And then based on that data that we have, that the college students were more happy in the room with coffee, we now draw conclusions. So was our hypothesis supported? Well, if I was hypothesizing that the ice cream would make them happier, no, it wouldn't have been supported. Does this alter the original theory? Well, probably not. The original theory was probably something about giving people food. Certain foods might make them more happy. So it doesn't alter the original theory. And oftentimes, individual tests don't alter a theory dramatically. It takes many, many tests and many, many tests of hypotheses, many, many studies to then change a theory dramatically. So can we trust the conclusions or the methods that I used in this study? Well, you really need to know a little more about it than I told you right now to know if you can trust those conclusions. Were there people jumping between rooms and drinking coffee and just hanging out in the room with nothing, as well as getting ice cream, or was it really controlled? And then who can we generalize the findings to? So if we tested this with college students, again, if they're happiest with the coffee, does that generalize then to the 5-year-olds? Does that generalize to 60-year-olds? Does that generalize to college students from India? Does that generalize to online students versus in-person students? So we need to decide those kinds of things. Maybe we need to do more tests. If we find that the coffee makes the college students happier, maybe we test online college students versus in-person college students, see if there's a different result there. And then with that, we then replicate. We publish that research, and we ask other researchers, hey, please test this, see if this hypothesis is correct. This is what we found, but we made XYZ mistake. Try to do it better in the future. You get your papers peer reviewed. You might put multiple papers together in a meta-analysis. We'll talk more about a meta-analysis later when we're talking about writing our own question papers. But then based on that, you might do new tests. So with that, I've mentioned a couple times that a single test would not necessarily dramatically change a theory. So now that you know what you know about hypotheses, now that you know what you know about theory, why doesn't a single test that might falsify a theory, why doesn't it necessarily change a theory dramatically? We might use the example of sociocultural theory with zone of proximal development, or even that spontaneous generation. All right, I'll jump in then. It seems to make sense to us, right, that spontaneous generation is not a thing that happens. We understand a lot more about some basics of microbiology and things like that. So it makes sense to us that, for example, grain does not become mice. Um, but when that's what people believe for 10 years, for 20 years, for hundreds of years, for thousands of years in this case, it's hard to say, well, no, that's not actually the right way, or that's not how this actually works, and here's my evidence. Um, you can look at the way that they've done the study. You can maybe criticize and say, well, I tested it and I didn't get the same result. And if, like those other researchers around the time of Pasteur, if you're not sterilizing your equipment well enough, maybe you are getting a different result. So it can be difficult to move from a theory. So, but that is what we're trying to do as scientists, is make sure that we have the best theories to explain and predict things within the world that we live in. And that's what psychologists are doing as well. The theories that we're using now, I suspect in the future, we will have different ones that explain and predict human behavior better. But for now, this is where we're at. So some of those that I've brought up to you are some of the developmental theories that we're using now. The sociocultural Vygotsky's, we still use that today, especially in education. Lerner's bioecological systems model and theory, Bronfenbrenner's bioecological systems. So those are really important big theories that are currently in use today, and we'll come to them again. So another way to think about this is that we can use this kind of research to solve problems. So there's lots of problems in the world. We have things like poverty, disease, chronic illness, pandemic, for example. We have things, people who don't have the same rights as others. And we can do research to help solve these problems. We can look at these problems. We can see what research exists. Does the research I mentioned earlier about group identity, does that have anything to do with voting behavior, for example? How can we get more people to vote? How can we get people to have more of a say in their own community versus the broader world? These kinds of things are real world problems that you could use research to work on. So you'd go to theory, things that have already been done. You'd get out in the real world. So talk with people who are suffering from this problem or working on this problem, collaborate with those people. You'd use these research methods that we're going to be talking about, experiments, qualitative studies, to try and figure out the answers. Then you'll get those results, get those conclusions, and send them back to people, give them to these policymakers, to researchers, do evaluations of programs that help people or are aimed at helping people. And eventually, through this cycle, hopefully you solve problems. So that is one thing I think is really exciting about psychology. And this is why I am an applied scientist. So I try to apply the work I do into the real world to help solve problems. All right, so let's talk about specific ways that we might do this piece of it, the research, the actual testing of hypotheses. So 3 broad categories are descriptive research, correlational, and experimental. So descriptive is pretty self-explanatory. It describes phenomenon. You're not trying to prove that one thing causes another thing. Some examples of this are things like observational studies, watching a classroom. So you're observing and describing how the teacher interacts with students, how the students interact with the teacher, how maybe a principal coming into the classroom affects the behavior of students. Surveys are actually also a descriptive form of research. You're getting descriptions of people's behaviors, their thoughts, their feelings. If you give students, let's say you give teenagers a survey to measure their drug and sexual behaviors, you'll often get not great data because teenagers tend to lie on surveys about those things. So you've got to decide with that what kind of research you want to do to get the data you need. Interviews, case studies, content analyses. Hopefully you remember these from your book. We'll cover them now and then more detail all throughout the class. We'll bring up examples of case studies, for example. Correlational research takes this a step further. it looks at relationships between different variables. So some variables we've talked about today are happiness. Another variable we've talked about is group identity. So when people have a strong group identity, are they more happy or are they less happy? Does it depend on the group that they're in? So you would look at the relationship between those two variables, that happiness and group identity. So correlations are written in statistical terms and a range from -1 to 0 and then back to +1. The positive and minus, the plus and minus, tells us the direction of the correlation. So whether it's a positive or a negative correlation, it's not a value judgment in any way. And the number, the size of the number, the closer it is to the -1 or the +1 tells us the strength of a relationship. So let's get some examples right here. This right here, let's just use some simple variables that may or may not make sense in this context. Let's use the example of ice cream and happiness. So let's say ice cream is on this axis and happiness is on this axis. So people who have a lot of ice cream, if we got this data, are not very happy. People who have very little ice cream are very happy. So this would be a negative correlation because it's kind of going down this way. Wish I could flip my mouse arrow around so it looked like it was pointing that way. So that is a negative correlation. The spread of this data isn't too wide, so it's probably a fairly strong correlation. So let's say it would be a -0.70. So that might be this correlation. This correlation, let's say again, this is ice cream on this side, this is happiness on this side. This really shows no relationship between the variables. So one person had no ice cream and also was not happy. This person had a lot of ice cream and was very happy. But this person had no ice cream and was very happy. And these two people over here, they had lots of ice cream, but were still very unhappy. So it shows us here that there's not really a clear positive or negative relationship. To me, just by my eye, a computer would find if this was positive or negative, but I would say this kind of looks like a positive correlation, but it would be very weak because the spread is very big. So it would be, say, a positive 0.06 as a correlation here. And then this is probably more likely what you would find for ice cream and its relationship to happiness. So give a lot of people ice cream or give one person a lot of ice cream, they're probably very happy. Give some people no ice cream or very little ice cream, they're probably less happy. So you might see this kind of strong positive correlation. You can clearly see a line going this direction, and the spread is not very big. So this would be a very strong positive correlation, something like positive 0.92, let's say. I'm just making those numbers up just to give examples of how we describe these relationships. And so in our analysis of these variables and how they're related to each other, oftentimes we'll use correlations. So here are another couple examples. So the number of yawns and the length of a lecture might be correlated. So the longer the lecture is, the more yawns. You might be feeling like yawning right now since we're talking about it. And then we might have level of attentiveness with the length of a lecture. As the lecture goes longer and longer, your attentiveness might get shorter and shorter. So the number of times your car brakes might not be associated at all with the length of a lecture. So my lecture today will go probably just a little before 9:50 because that's what we're scheduled for. And that's not really related to the number of times your car breaks down. Now, if we tried to graph the correlation between how often you get your car in for regular maintenance and the number of times your car breaks down, we'd probably find a strong positive correlation between those, especially as a car gets older and older. But a correlation doesn't necessarily mean that something is causing, that one of these variables is causing the other. So this here, that might be causal. I want to think of an example that is not causal. Oh, here's a good example. I knew I had thought of one before. So there is actually, research has found this, there is a strong positive correlation between ice cream sales and violent crime. So if we use ice cream on this side, this isn't the actual graph from the paper describing it. This is just an example of a positive correlation. So let's say ice cream is over here, violent crimes. So as you see more ice cream sales in any given day, that day also tends to have more violent crimes reported. So are ice cream sales causing violent crime? Or is violent crime causing people to go out and buy more ice cream? What does this data mean, that these are strongly positively correlated? I see Julie has suggested hot weather. Yeah, and it makes people cranky. Very good. So it's probably some other variable that might be causing both of these things. Or maybe it's some other cause that is causing other things, that's causing other things, that then leads to these two things being related. Yeah, in this case, there is a strong positive correlation between ice cream sales and violent crime, because there tends to be more violent crime during the hotter days of the summer, and there tends to be more ice cream sold on those hotter days of the summer. So yeah, that hot weather is doing that. Now, there are correlations between things that aren't really related in a causal manner. Is this what you're saying, Don? That there are correlations between things that are not related in a causal manner? And by finding those, and we need to find those correlations to understand how things are related in this world? Yeah, and you're exactly right with that. There are lots of relationships that exist in the world between different variables: happiness, group membership or group identity, the strength of your group identity, political affiliation, height, heat, violent crime. There's a lot of different correlations that exist in the world, and some of them are causal, some of them are not. And it's our job as scientists to figure out, well, what is causing some things, or what things are just seemingly related to each other. A part of that is just curiosity. Part of that is so that we can solve problems that exist. So another interesting correlation that is, well, yeah, I think the ice cream violent crime example is a good one. Essentially, just because two things are correlated does not mean that there is a causal relationship between those two things. So this is something that'll definitely be on your final, that correlation does not mean causation. Some things are related, but it's not a causal relationship, so we need to be clear about that. If we do find correlations, there might be a causal relationship, right? So the heat and ice cream sales, if we measured on this side ice cream sales and this heat, that might be causal, or maybe indirectly causal, right? So, but the ice cream sales and violent crime, those are related, but they are not causing one another. All right, some other aspects of research are longitudinal designs. This is where you follow the same group over a long time. So the best longitudinal study would take a child from in utero all the way to the time of death and measure a bunch of different things. There's some cognitive studies that have been done throughout adulthood that have looked at things like inductive reasoning, numeric ability, verbal memory. And through that, we've realized that people retain a lot of cognitive abilities until very late in life, until the 80s about. And especially with help, that can even be extended. I'm not actually sure of the correlations between COVID and crime. So I'm sure you could find relationships there. But yeah, we definitely need to be clear if those correlations are causal or if they're just a relationship, or maybe they're caused by another third variable, or if there are multiple variables that are causing both these things. COVID and toilet paper. Yep. As well as bidet sales as well. I just read that the other day. How the sales of bidets jumped so much as well. So another thing that we could do to research and get data to answer questions is experiments. So to do an experiment, we really would want to do that if we wanted to determine cause. So a survey might be a really good way to get at relationships between variables, but if we wanted to get at cause, doing something like an experiment would be a better way to do that. So this experiment picture is a good example. Will student test scores be affected by distracting sounds in the testing environment? So my hypothesis in this case would be yes, they probably would be affected. That's my hypothesis. So to test that, we can take one group, that's the control group in this case, and give them a test that they've been studying for. Maybe all these students are in the same class. So we take all the students from our class today, and some of them we place a person playing ukulele music in their house while they're taking the test. And the other one, we just let them have their normal environment or maybe a testing center or something like that. So that would be one way to control some of those variables, right? There's other variables that might exist, right? So these people over here, maybe half of them are actually sick versus the people over here, maybe all of them are healthy. That's another thing that can happen. But we can control for some variables, right? We can control that this group has no noise and this group has a lot of noise. That's what we're trying to do with an experiment. So then we can kind of rule out, well, yep, the people in the control group did do a better job. And so experiments look at two or more variables, and you need to manipulate at least one of those variables in order to determine if it causes any change. So in this case, our variable that we're manipulating is the noise level. So one room is quiet, the other room is noisy. Like I said, there could be other variables affecting this, right? The illness of the students, how much sleep they got, their diet, things like that. Maybe just by happenstance, this whole group was studying more than this group. That might make them do better. So we can do our best with an experiment to try and control for more and more of those kinds of variables. Taking the same example of the control group and experimental group coming from one class, how might we control for not just the sound level, but also student study habits? How might we make sure that we have kind of an even distribution of students in here? Some students studied a lot, some students didn't study very much, and some students here studied a lot versus not very much. How could we do that, do you think? Looks like Parker has a answer or comment on that, or even a question. Go for it, Parker.
You could require more homework as part of the curriculum so they study more.
Yeah, so you would try to maybe get them all to have the same level of time with the material by giving them all more assignments, and those assignments all help them study. Yeah, that's a good idea. Any other ideas for how we could try and control for students studying more versus less? Yeah, another thing we could do is ask each of these students how much they studied. So this person reports 1 hour, this person reports 2 hours, this person reports 3 hours, this person reports 1 hour. And then we can control for that statistically afterwards, see if there's a relationship there. Yeah, those are two really good ways. Try and control how much they do study. Maybe one way we could even do that, especially in an online setting, is only allow students to study for, let's say, 2 hours total. They can only study and read the book for 2 total hours. And to get their points, they have to read all that 2 hours, make that part of the class. So everybody's studying those 2 hours. Then that's even between them. We have the control group that has no music, experimental group with music. Then hopefully we have controlled for a few more variables. We're now controlling for study time. We're controlling for the sound level, and then we're looking to measure the scores. So that's 3 total variables there. So yeah, really good ideas. So it can be difficult to control for all variables. So one way that we try to control for a lot of variables that we can't know, because we also mentioned another couple, we mentioned sleep. How can we make sure that it's not just all the group over here that slept 8 hours the night before versus all of these students slept 3 hours? Yeah, diet can affect test scores and how they perform on that day. So to try and get at all of those variables that you can't necessarily control for, because in reality, you're not going to be able to necessarily give a group, unless you have a lot of money to like buy food for all these people and find a good diet that works with everybody's dietary restrictions. So rather than actually like giving students meals, changing their lives so they can all sleep the same and doing all those things, another way to kind of spread out those differences is to randomly assign them to different groups. So this works better in bigger numbers. Let's say we have 1,000 students. Then we randomly assign them on the day they arrive to control group or experimental group. A computer or flipping a coin will send them either to this room or this room. Then hopefully, especially with a large group, we hopefully get a bunch of people who studied only 1 hour in here, as well as a bunch of people who studied 1 hour in here versus studiers or people who studied 4 hours in here, people who studied 4 hours in here, people who had poor diet in here, people who have poor diet in here, people who have good diet in here, people who have good diet in here. So we try to get rid of a lot of those other variables by randomly assigning to these different groups. And so hopefully that gets rid of things like diet, sleep schedule, how much they studied, and we can focus on the sound in the rooms. So random assignment is a really important piece of experimental research. The bigger group you have, and if you randomly assign, you're going to hopefully get rid of a lot of those similar things. Or you're going to spread out those other potential variables that might affect your results. So with an experimental study, you have the IV, the independent variable, and this is the variable that the experimenter changes or manipulates. So in our example just a minute ago, that is the music. We've manipulated that. One group has the music, the other group does not have the music. The dependent variable is, I want you to think of it as the final measured variable, the final thing that the research is interested in. So we want to see if this changes based on our change and manipulation of the independent variable. So in our example with the rooms, what would the dependent variable be? What are we wanting to measure in the end? For this, you could probably just write it in the chat. Yeah, the grade on that test, exactly. So that test score, very good. So the IV, the independent variable, is our manipulation of the music. One room has music, the other does not. And the dependent variable, our final measured variable, is that test score. Great work. All right, so we just talked about random assignment. So here is just a visual example. If we have purple people and orange people, we want to spread those out between those groups. So the purple and orange just is indicative of any other kind of variable. This group got a lot of sleep, this group got no sleep, this group studied a lot, this group did not study a lot. We want to split those out between the groups so there's a mix of all of those other variables. So validity is an important thing. You could think of validity or the word validity as synonymous with truth or accuracy. So are the conclusions we draw from our experiment, are they sound? So are they actually true? Are they accurate? So can our result, let's say we find that the group who is taking the test in the quieter room, so can we attribute that result to some outside force? Did we actually end up having everybody who slept a lot in the group that was in the room that was quiet? So can it be attributed to that? So, or is the measure that we're using to measure things, is that measuring what we're supposed to measure? I know I said the word measure a lot of different times there, but I'll just slow it down. So is the measure, let's say the survey or the scale. So we have a survey about happiness, for example. Is it actually measuring happiness? That's what we're getting at with validity. Did our experiment do a good job to actually say the music made the difference? Is our measure of happiness, is our survey, for example, is that actually measuring happiness, or is it measuring something else? As an example of this, my daughter's doing online school right now, and at the end of each day, she's given a short survey that basically says, well, how was your work today? Were you happy or excited? Was it just kind of blah? Were you sad or were you frustrated? So she's got those 4 response options. So it's supposed to be trying to measure if she is frustrated, sad, happy, or just fine. She doesn't ever want, she's been a little frustrated, especially today. She was kind of frustrated with her work, but she doesn't want to give the teacher a bad rating or like a sad face or a frustrated face. She wants to put on a happy face. She wants the happy emoji to be her answer. So is that measure actually measuring what the teacher wants to measure? In my daughter's case, no, not at all. So I think we're going to have to send an email and be like, hey, I know she's putting happy faces all the time. We've tried to go back and change it, but it won't let us change the response after it's already been put in. My daughter gets really upset if we try to answer honestly. She wants to put on a happy face, which, yeah, it is what it is. Just a good example, though, that measure is not measuring what it's supposed to measure. Let's say we wanted to measure IQ. One thing we could try and do is measure someone's head on a scale. We try to measure the weight of their brain. Say they lie down on the ground, they put their head on a kitchen scale, and they see to a very precise number what their head weighs. Do you think that is a valid measure of intelligence? You might not type this, but hopefully you're saying to yourself, no. Yeah, that's good. Good. No, it's definitely not a good measure of intelligence. I mean, that would suggest that as I tried to grow my hair out a couple of years ago, I was gaining more intelligence because my head was getting a little more heavy. So you could definitely manipulate that test score, right? So no, we definitely want what we're measuring to actually get at what we want. So if we're measuring intelligence, you want to be able to actually measure intelligence. We'll talk about some problems with IQ testing in future chapters, but just a good example. You're not going to measure intelligence by putting someone's head on a scale. Experimenter bias is something to be concerned with. So I think that my experiment with the music in the 2 rooms, that's a good study, that the group that's in the quiet room will do better. So that might affect how I set up the rooms. Maybe I also clean the room that's going to be the quiet room better. Maybe that has an effect. Maybe I know who's getting put into each room. And so I'm a little nicer to the students who are going into the quiet room. So the experimenter bias comes out in ways like demand characteristics, where the experiment tells the participant how to behave, usually unintentionally. So some surveys, for example, that I've used on purpose in life. As students do them, I sometimes have them write open-ended comments, and they often think that they know what I'm trying to get at. Sometimes they're right. Usually they're kind of off, but the point is sometimes the way that I'm asking questions, in what order, kind of tells them what's most important to me, the researcher, and it kind of suggests how they should behave. And that's not good. I need to make sure I don't do that so I get good data. So experimenters' expectations might unintentionally influence the research. So by cleaning one room more than another, for example, being a little nicer to some participants. And then participants can also have bias. If they think they know how they should act, participants might want to try and make the researcher look good or give them the answers that they think that they want. Maybe the participant also thinks the way the researcher thinks, or the participant thinks they know how the researcher thinks and likes that way of thinking, and then tries to make the study go that way. So it's kind of a interesting train of words that might have been confusing, especially in this context. But participants tend to either act in ways that are kind of trying not to get the researcher to get the results they want, or trying to get them the results they want. But what we want as researchers is participants to respond normally, to behave as they normally would. That's why things like observational studies are really good. If we can observe in a way that participants don't know that they're being observed, and we can measure things in a valid way, we can get a good assessment of how people think and behave. So a really good example of this is Clever Hans the horse. Clever Hans supposedly could do math. So Clever Hans is a really good example of researcher expectation and affecting the participant. So in this case, think of Hans the horse as the participant, and think of the trainer as well as the people watching as the experimenters. So what the owner of the horse would do is bring the horse out and say, hey, everybody gather in a circle. I have a horse that can do math. Call out any kind of math problem, and the horse will clomp its feet just the number of times to answer the math question. So this person gets up and says, hey, what is 2 plus 2? And the horse will click. This person will say, wow, that's amazing. What's 3 times 3? I'm not going to click into my microphone 9 times. I think that'd be annoying. But the horse does it, and everybody's amazed and astonished, and they throw money to the owner, and the horse gets a carrot, and it's very happy about that, or maybe a little bit happy about a carrot. It doesn't want money, obviously. It's a horse. But can this horse actually do math? I mean, hopefully the answers again here are no, the horse cannot do math. What is happening here? If the horse can't do math, but we're seeing these behaviors, what is happening? How is the horse getting the correct answers? So feel free to put your hands up. Feel free to put your hands up as well as, you are putting messages in the chat. Yeah, so it looks like we've got a couple different ideas here. So we've got the horse has been trained to respond to a specific stimulus. Yeah, so maybe with that, maybe they're getting cues from a trainer. They're getting a specific stimulus, and then they respond. So they know when they're supposed to click 4 times or 9 times. Maybe it stops clapping when the people are starting to cheer. So it's learned to look at body language. So the horse might be reacting to certain words, just like a dog when you tell them to sit. Yeah, these are all really great ideas. And it's in large part a lot of them. So a lot of them together. But a big part of it is that the horse has learned to watch human behavior. So when people are watching the horse and it's getting close to an answer, let's imagine you said 2 plus 2 and the horse is going. The horse has learned that people are going to get anxious. They're going to start holding their breath. Their behavior will be different. And then when it stops there, the people will then cheer. So it kind of knows the body language of people, and as well as the body language of the trainer. So based on that, it has been trained to respond to these human behaviors. So it doesn't know what 2 plus 2 is, but it does know when people behave this way and I stop clamping my hoof, I will get a carrot. So that's what that horse knows. And so that's why it's like these people are the experimenters. They don't realize they're affecting the horse's behavior, but really they are telling the horse exactly what to do. And when we're talking about experiments, we've got to make sure as experimenters that we are not telling people exactly how to behave. So just kind of a funny story, I think, related to that. Any questions at this point? Feel free to raise your hand at any time or type a question in the meeting chat that we can go over. But just a reminder, please do put questions as we're going through. If there's terms that I've used that have confused you, things like that. I know these first couple weeks are really, really dense with a lot of material. All right, so some ways to solve these problems are placebos and double-blind experiments. We talked about these last time, so I won't ask for examples again. But double-blind experiments are experiments where the participant nor the person delivering the experiment know which group the person is in, know necessarily the hypothesis being tested. Maybe it's a lab assistant actually running the experiment, and the researcher is like a room away watching on a camera. So they're collecting the data. So a placebo is something like a harmless substance or a separate treatment that can help the researchers tell if the result came from participants expecting something to happen. I use placebos a lot in my work when I'm creating tools for people. I make online toolkits for people to gain purpose and be more pro-social. So essentially, they're doing these online activities. So one group is doing the activities that I've created, and the other group is doing some other activities that are kind of related. Most of the time, I give them cognitive memory enhancing activities, which are still a useful thing to learn, but aren't actually related to doing more pro-social behavior or having more purpose in life. So it's still helpful to them, and it makes them feel like they're doing something, but it shouldn't actually affect their purpose or their pro-social behavior. So they're getting a placebo, they're getting a separate treatment. Double-blind experiments, again, neither the researcher nor participant knows which group they're in, if they are getting a placebo or if they are getting the actual thing. So all of these different methods have their pros and cons. Obviously, you want to understand the relationships. You want to do descriptive research to describe how things are happening. You want experimental research to tell you what is causing what. You want correlational research to tell you what relationships exist in the world. So with that, it's best to use a combination of these different methods to answer any kind of research question you have. No one is really better than another, except at getting very specific things. So experiment is best at getting causal data. It's saying the quiet room caused the people to get better test scores. If that's what you want, if you want to get a causal data, you need to do an experiment. But that doesn't mean that correlational or descriptive research is not valuable. It's still very valuable to see those kinds of relationships and describe how and why things might be happening. So population, so some other terms in relation to research, and then we'll jump into chapter 2 very soon. So population is an entire group. So you might think all the students at Salt Lake Community College are one population. Population of the world is one population. The population of the United States of America. And from that, you might sample a specific group. So if we're taking the students at Salt Lake Community College, you might sample, let's say, 20 students from each major. So, and then you get a pretty good sample of the population of Salt Lake Community College. So that subset, or that sample, is a subset. So if we wanted to get a good sample of the population of Salt Lake Community College, could we just take all psych students? Would that be a good representation of the entire population of Salt Lake Community College? I don't know how many psych students there are right now. Let's say there's 700. So would that be a good, I see some answers no. So why wouldn't that be good, and how might we get a better population as well? Yeah, that's a good point. Not all students at SLIC are psych students, right? So there might be some differences between psych students and other students. So let's say we're looking at the relationship of, let's say, study habits, memory, and intelligence. Maybe students who are in the psych program might have better memories because they learned about memory in their general psych class. So they know some more tricks, right? Maybe people in the psych program are a little different in other ways too, right? You might have people who are, I don't know, I can't think of any accurate generalizations of psych students versus other students. But there might be specific differences of people who choose to go into psychology versus people that choose to go into any other field. So you want to find out if those differences are important to that population. So you want to do a better job at sampling rather than just pulling in psych students. Even though it could be easier, especially as a psychology professor, getting psych students is probably a lot easier than getting students in other departments. So random sampling is really good. It's when you take a random selection from that population. So rather than say 20 from people from each major, say, okay, I've got a computer list, a roster of every student at Salt Lake Community College. I need this computer to give me 400 students, and it just randomly picks 400 students. That would be a random sample, and with a large enough random sample, you get a really good sample that closely resembles the population. So you can see here there are people that are very different. Actually, it looks like they've kind of copied and pasted some people here. But you've got a good mix of those people in your sample. So that's what you want. You want a sample that closely represents your entire population. When we're talking about things like the entire population of the United States of America, that is a big population. It would be very difficult and very expensive to measure all of them. You might have seen people asking you to do the census recently. So they're trying to get every single person in the population in that census. So that is a tough job. It's very expensive. It takes a lot of time, takes a lot of people. But if you take a sample of, I don't even know how, I guess I have a computer right in front of me. I could look at how many people are in the US. But let's say you get 10% of the population in a random sample. That would be a pretty good picture that would pretty closely resemble the population of the United States of America. All right, so settings are important in your research. So where are you doing your research? Are you doing it in the real world? Are you doing it in a laboratory? When you are in the real world doing naturalistic observations, it's really good to look for normal natural behaviors, but it's hard to control for things like having a group with sound in the room versus not. In a laboratory setting, you could control for that. You could give one group a bunch of sound when they're doing a test versus the other not, but their behavior might be different because they're in a laboratory setting. So when you've changed the environment, you might change their behavior. So decide on, we'll do this activity when we get back from a little break. So we're going to get into some groups. I've actually already created them. I think I'll pull over my Teams screen so you can see that, and I'll show you where to get to these groups. So hopefully you now see my Teams screen. Hopefully it doesn't mute it. Maybe I'll open up a new Teams screen. That might work better. So it doesn't mute this meeting as I'm trying to show you it. But when you go back to the general page, you should see a couple groups beneath the general page. So find which group has your name, and then in a few minutes when we come back from a short break, you will decide and choose the methods for your own study. And of course, my Teams app is opening slowly right now when I need it. Come on, Teams. All right, while that's loading, let's talk about the instructions for the group activity that we'll do in a few minutes. So essentially, you'll get in your groups and you will decide how you would empirically study your own research question. So what kind of variables would you be interested in? You can pick anything from ice cream to, I don't know, war and poverty. You could think of any kind of variables. You could think of something that you've come across in your research. You could talk about IQ, things like that. So talk with your group about what variables you might want to look at. Assume an infinite budget. Assume you could look at anything and everything. So what variables do you want to look at? And what are your operational definitions? How would you measure those variables? So how would you measure things like happiness? How would you measure things like poverty? How would you measure IQ? So think about your operational definitions. What sample will you use? Will you actually get the entire population of the United States of America? Remember, this is imaginary, so you could do that in your example here. Or are you going to sample 75 people from every state in the nation? What are your ethical concerns? Hopefully you've read the chapter. We haven't covered ethics today, but hopefully you read the chapter on ethics. So what are things you need to be concerned about? And then what kind of methods are you going to use? Are you actually going to do an experiment? Are you going to interview people? Are you going to give them surveys? How are you going to get the data for these variables? So you could think of these questions or make your own questions. So how can we help students learn? Why do heroes act heroically? How is weather related to emotions? How is music related to emotions? What causes bullying? What parenting style is best? So those are some example questions that you might look into. Feel free to use any of those or come up with your own question and your own variables as a team. So my other Microsoft Teams window just opened. So hopefully you can see that now. So right here below the general, we have this little meeting button. So what I would want you to do is find which of these groups corresponds with your last name. So if your name is A through E, your last name, the first letter of your last name is A through E, you're in this group, F through L, this group, M through P, this group, and Q through Z, this group. So some of these groups will be a little bigger than others, but that is all right. So go into that group and then meet. If there's already a meeting there, just join that meeting. If you're the first one in that box, click the meet button and you'll start your own meeting. Don't close this general meeting though. We'll come back to this and I'll be able to jump through all these different groups. So jump into your group after we come back and you'll talk about the methods for your own study. Any questions on how to get into groups for when we come back from our break? We'll come back at 8:41, maybe 8. Let's do 8:42. All right, feel free to post any questions in the chat. I'm going to mute and go grab some tea during the break. So we'll come back at 8:42 and start these group meetings. All right, students, we should come back to our teams. Don't hang up in this call. Just go and join your group in based on your last name. So it looks like we've got a group already in A through E. So anyone in F through L, Q through Z is already in there. So basically just do this. If you're F through L, if your first letter of your last name is F through L, come in there, create a meeting just by clicking this little button, and I will jump through the different groups, and I will leave this up so that you can see it as well if you flip back and forth, or if you've got the slides up yourself. Come up with your own study, figure out what kind of variables you'll use, those kinds of things. I did not. I haven't done their proof yet either. All right, for anyone still confused and here in our main group, hopefully you see my other teams window here. So right now we're in this general meeting. So all you need to do is click on Teams on the far left, open our class, and then rather than clicking in general, just click the classroom group that's relevant to your last name, and then join the meeting that exists. So hopefully that explains it, and I will start jumping through meetings, but I'll come and check this board still as well. to come back to this meeting. So hopefully everybody's coming back here. As we do, I had asked Richard to talk about their study. So if Richard is back, let's hear what your group decided, what you're studying, variables, those kinds of things. And thank you as well.
Cool. All right. We were just going to look at what type of pet makes people the happiest. And so we would basically, the type of pet would be the variable. And happiness, I guess, we didn't really get into operationally defining what happiness is. But anyways, so the samples would basically just be, we could pick out 6 different pets. We're going to look at dogs, cats, goats, chameleons, birds, whatever. Since we had an unlimited amount, we could, do 1,000 people. One of the things that we thought we might be able to do to measure happiness or response to happiness was if we had some sort of immediate measure to measure the change in hormones, the happiness hormones. I can't remember which one, but change hormone levels. The change in hormone levels when you walk into the door back home and you see your pet and see which one registers the most. So if you see a dog and happiness hormones go way up, great. If you see a bird and they go even higher, then we can kind of look at that. We could also do surveys to basically get a general to each participant, get them to fill out surveys on the general happiness in general, and kind of compare some of those results and see what goes on. And we didn't really find any ethics concerns because, there weren't really, I don't think.
Yeah, great work there. So with that, you've got some different examples of different kinds of methods. So you've got a observation of people with pets. You can ask people how they feel about their pet. So that's kind of like a survey there. And then you can measure those variables in different ways. Hormone levels, for example, a survey response, so a self-report, that would be a great way. So it's all right you didn't look at operational definitions. So some groups did, some groups didn't. Some groups went in more detail on things like samples. Some groups did have ethical concerns. So great work there. I think everybody, these group activities, they always seem to take longer than I expect they will. But I think every group got something good out of it, got a good sense of what you generally do in a study. So even with that short amount of time, all the groups came up with some really great ideas for studying things, how to study their variables. Some groups made experiments. Some groups went really big and extravagant, things that would be completely impossible without a whole lot of money. And some groups did very realistic things that you'd actually be able to do. So great job to everybody. Is there any other member of a group that wants to share something that they thought was really interesting or their entire study? Feel free to raise your hand or comment in the chat that you want to share. Go ahead, Julie.
And I'm not sure who it was that said it because I couldn't quite understand when we were in the group, but someone came up with we were going to study weather and happiness, or emotion, I shouldn't say happiness, weather and how it affects your emotion. And someone had made the point of what would it be like if we had displaced someone who is indigenous to, say, like an Eskimo, to somewhere that was cold, and then put them near the equator. And how would that affect them as opposed to someone that, was born and raised somewhere and they stayed there their whole entire life?
Yeah, that's definitely a big concern of ethical concern of, can you move people to a different place? If they've agreed to and they know what they're getting into, things like that, it would probably be acceptable if they volunteered and they know the risks and they're saying they will. But yeah, that would be a really interesting study to see how people react to weather and emotion in different climates compared to where they're from and where they've lived 20, 30, 40 years of their life and whatnot. So There's another comment here. I'd also be curious to know if emotional attachment plays a bigger factor and what kind of animal it is. So yeah, there's a lot of different variables you can measure in all of the studies that you came up with. A lot of the conversations that took the most time in each group were about the variables and, well, should we add this and this and this and this, or should we keep it narrowed down to this and this and this? So I think everybody did a really great job there. Any questions coming out of there that you're still really confused on about methods in general and how we do science as psychologists? Go ahead, Don. Either type in the chat or go for the microphone as well.
So like, is it just kind of a guess and check, I guess, or is there like more proper methods or studies than others? Like, I don't know, or it probably just depends on the study. I don't know.
No, I think that's a really great question. So a lot of what I had you just do was kind of just threw you out there. I'm like, so here's a couple really brief basics of research methods. Now make your own study. But you're absolutely right. There are better ways to do studies and worse ways to do studies. And depending on what you're studying will depend on a little bit what you do. For example, for research in heroism, at this point, there is still not that much research in heroism. So a lot of the research I do is things related to heroism, like background reading. So in any kind of study, you should have already done a lot of background reading for a lot of concepts, like say the bystander effect. There's a lot of background that's already been done. Tons of studies have already been done. So you should read a lot of that, or at least some book chapters on it, or some of the newer articles that kind of summarize a lot of the research. So that's kind of where a lot of studies start, is by learning about the topic. So depending on the topic, there might be a really big amount of stuff to read. So you kind of start there. You look at, well, I'm really interested in heroism, pro-social behavior, pets, how weather affects emotions. I have a colleague who studies how nature affects emotions. They're really interested in green spaces, whether it be in an office building versus outside at a lake, how that changes your well-being and your general emotions in the immediate moment and long-term, which I find really interesting. So essentially, we all just read a lot of information of past studies and see how other people have researched these things. We try to find areas that are missing. So let's say a lot of people have studied green spaces in offices, but not as much, say, in the home. So you might do a similar kind of test that someone's done in an office, like one room with green, one room without green, one room with fake plants. So 3 total experimental rooms. You might do that in a home, or you might compare different parks. So you look at what's been done, and then depending on that, you'll say, okay, so one area that's kind of missing that we need to know about is this specific area. And then based on that, you'll choose what kind of samples you need. If you're looking at office buildings and green spaces, you probably need samples of people who are in office buildings, right? If you need people who are in nature, you'll look for samples of hikers, for example, things like that. So yeah, depending on your question will, I guess the most important thing in research is that question and those variables that you're interested in. And then based on what people have done in the past and what kind of data you want to get out of it, will help you know what kind of methods to use. Because in the case of the green spaces in an office, an experiment might be a really good one there. But if you don't know a lot about heroism and you don't know very much about heroes at all, maybe doing interviews with heroes is the best first place to start. So as an example, that's where we're kind of at with the research in heroism, is I'm doing interviews, especially during this pandemic. We've actually been able to do more because people are getting more familiar with Zoom calls and meetings like this. So interviewing heroes all around the world to look for commonalities. Once we find those commonalities, maybe we'll try to instill those commonalities in people and do some experiments. So it's a really good question. Like, how do you go about doing these studies? Are there better ways and worse ways? Yes, there definitely are. In just this one class on research methods, you won't know all the ins and outs of how to do it, but hopefully you have a little clearer idea of what's better, what's worse, what kind of studies, like a survey versus an experiment, will get you what kind of data. So does that help with that question, Don? Or does it inspire other questions that you have as well?
Yeah, no, I think that was good. I don't know if I really knew what my question was, so it was good.
Yeah, I thought it was a great question. So thank you. Any other questions? All right, well then in that case, we'll jump forward in the slides. I think we'll skip over ethical research. I feel unethical and terrible about doing that, but hopefully you've read it in your books. Some of the biggest things are these 4 points: informed consent, confidentiality, debriefing, and deception. Informed consent is hopefully you have a basic understanding of consent, that people are agreeing to do the study. Informed consent takes that a step further, that people are agreeing and they also know what's going to be happening in the study. So what kind of risks might be involved, if they're going to have to move across the world to a different location, or if they might feel uncomfortable with some example stories that are given, if a medical trial, they might have certain side effects, those kinds of things. Confidentiality is, so informed, the informed piece of that is really important, that you inform them of what's going to happen. And that'll be relevant with deception too. Confidentiality is keeping people's data confidential. So when I publish a paper, I don't say, hey, this specific student named Jimmy at the school said this about their purpose in life, because I don't want someone to read that or that to come back to them. They might say that even in a public forum, but I don't want my data tied to that individual. So I'll talk about, on average, all the people we studied, the entire sample, people said, or people had this much purpose or not this much. A lot of people had these kinds of comments to say. I'll talk about it more generally. So not publishing data in identifiable ways. That is different for one heroism study that I'm running right now. We are interviewing people who've been awarded for heroism, and they're people who've been awarded, like, so they're public figures essentially that have been recognized. So if we talked about their stories, they would still be recognizable. All of them were asking if they would permit us to publish their names. So in this kind of case, I'll say something like, well, Wendy Addison said XYZ. This is the same as this other whistleblower, things like that. So, but generally you want to be confidential. It's really uncommon that we're able to do this kind of study and not be completely confidential. Debriefing is essentially telling the participants at the end, making sure they're clear, that they know what the study was about. So if they did a survey, explain this is why you answered these kinds of questions. If they did an experiment, make sure they understand what was going on, and then make sure they're leaving without any bad feelings or that they get the help that they need. So let's say you did a medical assessment and you find that they have a heart problem. You want to make sure you let them know that and give them resources where they can get help. If you are, another good thing is make sure that they get a new skill or something. So that's why a lot of my, not control groups, but the alternative groups that do activities, that's why I give them an activity that actually does something good for them, that helps them develop memory skills. And make sure they leave with your contact information. And then try not, as for deception, a lot of social psych experiments used deception for a long time. It was kind of a badge of honor of how much you could lie to your participants. But now we try not to use it unless it's absolutely necessary. And depending on what you're studying, it might be necessary to kind of bend the truth or lie completely about what you're doing. But generally, you can tell people what you're doing, even if it's more general what you're telling them. So I don't tell participants in the beginning, hey, I'm going to give you this specific scale of purpose and this specific scale. I'm going to say, I'm going to measure things like your well-being, things that are important to you, I'll be asking you questions about those things. And then I give a debrief and tell them exactly what's going on. With all of these, schools and research institutions that get any federal funding for research have IRBs, institutional review boards, that will look over your research. You'll propose it to your IRB and they'll say, well, yep, you look like you're getting informed consent, you're being confidential, you're doing debriefing, you're not using deception, but we're still worried about the safety of the participants in this way. So you have to go through some regulatory boards if you're at any institution that gets any kind of federal funding, even if you yourself for your study is not, even if you are not getting federal funding for your study. So with that, learning all these things and learning about psychology is a lot about you. Hopefully a lot of the things we learn in this class you can apply to your own life, your own development, the changes you're seeing in your family members, yourself, the work that you do, these kinds of things. So let's jump forward to chapter 2. We're not going to be able to get too far through this, but I guess as I'm jumping into chapter 2, are there other questions before we leave chapter 1? I know it's a really dense chapter and we kind of sped through. All right, I don't see any hands raised, so let's get a little bit into chapter 2. Hopefully you have started reading chapter 2. Don't forget to look at the due dates for the different chapters in your schedule and the syllabus to make sure that you're turning in the chapter 2 smart book by, I don't have it in front of me, but I believe it's next Tuesday at midnight. I believe chapter 1 smart book is due midnight tonight. All right, we'll do that another time. So let's watch this little video about mirror neurons and start talking about the neurology of the brain. Trying to figure out where my computer's decided to open it. There we go.
Someone in the chat.
Yes, really good point. So Canvas is being serviced from the 4th through the 7th, I believe it is. So definitely make sure that you're doing your work in a span of time that Canvas is working. I believe you can access Canvas itself still during that time, but a lot of other features like My SLCC will not be accessible. I got an email with a direct link to Canvas. So Canvas itself might still work, but My SLCC, your email, things like that may not be working, and Canvas may not be working either Friday through Monday. So with that, you will probably need to take your chapter 2 smart book before Tuesday at midnight. So just make sure you log on and get that done. You can do it early as well or late. So a sugar pill, and Don is asking a sugar pill and not the real treatment, that would be an example of a placebo. Yeah. So the activities that I sometimes give students that are memory activities, those are similar to placebo. It's a different group. It's not technically a control group. It is more similar to a placebo. I think that is all the questions. Let's watch this video so you can learn a little bit about mirror neurons.
If you read some of the less reputable corners of the internet, you might have heard strange things about mirror neurons. According to some people, they are why we have empathy and ESP and telepathy. It probably goes without saying that most of that isn't true. They definitely don't give us superpowers, and there is conflicting research about whether they're the basis of empathy. Even if they're not, though, they are still a very cool part of your brain, and probably they help us learn from other people. The name mirror neuron comes from the fact that they fire both when you do something and when you watch someone doing something, even if you don't move a muscle. Basically, it's as if they mirror the neural activity of the person actually doing the thing. And they were first discovered in macaque monkeys in the early 90s. The story goes that one day, while a monkey had thin needle electrodes inserted into individual neurons in their brain, some of the graduate students, well, they went and took a lunch break. And while one of those graduate students was eating in front of the monkey, all of a sudden, there was neural activity in the premotor region of the frontal cortex in the monkey's brain. This region would normally fire if the monkey was moving, like reaching for food or eating. But those neurons were firing while the monkey was motionless and just watching someone else do those things. Further research started mapping out exactly where these neurons were, and they're remarkably specific. Like mirror neurons that fire when an experimenter grabs a piece of food wouldn't fire if the experimenter used tools to grab the food instead. But the big question was whether this happened in humans too, because these neurons were in regions of the brain where monkeys and humans differ quite a lot. Of course, your average human study participant is a little fussier about getting electrodes planted into individual neurons inside of their brains, so scientists used electroencephalograms, or EEGs, to look for mirror neurons instead, as they record neural activity through the scalp. Researchers had 20 subjects watch an experimenter demonstrate some motions with their thumb and index finger, and then perform the same motions themselves. And turns out some regions of their brains did act like the monkey's mirror neurons. Parts of the motor and premotor areas of the frontal lobe, for example, as well as where the parietal lobe meets the temporal lobe, an area involved in vision and focusing attention. But knowing that they're there and where they are doesn't tell us why they're there. Many neuroscientists now think that they help us learn from other people through observation. Take a 2009 study, for example, which looked at how these parts of the brain are active while people were being taught how to dance. The researchers used a game similar to Dance Dance Revolution and varied whether the participants were taught the steps using symbols on a screen or a human model in addition to the symbols. And they found that parts of the mirror neuron network really tune into human actions. For example, the superior temporal cortex was more active while watching a person demonstrate the dance than the symbolic breakdown of the steps. But perhaps more to the point, the participants' performance on the final dancing test was better when they had a human to watch, which suggests that these regions support observational learning. Human mirror neurons aren't exactly the same as the monkey ones, though. Ours seem to care about the actual movement, while theirs are more strongly tied to the movement's meaning. Like, say you grab a water bottle the way you normally would, and then you put it down and grab it with your hand upside down instead, which makes drinking it a lot harder. It's basically the same muscle motion either way, but one serves a meaningful function. In a macaque, watching the meaningless action might not activate their mirror neurons. But in people, the mirror neuron regions of the frontal lobe activate regardless of whether the action makes sense. All that matters is the actual hand motion. It's possible that this helps explain why humans are so good at learning by imitation. Part of our brain is always paying attention to motions that seem meaningless, just in case we can learn from them. Now, you might be wondering where empathy comes into all this. Well, when you think about it, if a part of your brain activates the same way when you're observing an action as when you're performing it, then it isn't that far of a stretch to think that these mirror neurons could be involved in feeling part of what someone else is feeling simply by seeing them express an emotion. And although this would be very cool if it were true, the research to date is kind of all over the place. Like, one study did find that mirror neurons activate when people empathize with characters in scenes. In one scene, for example, the 18 subjects had to identify the emotions felt by both a son who was bringing home a failing report card and a dad who hasn't yet seen it, for example. And in addition to identifying the emotions of both characters in the story, they had to guess what both characters would be experiencing if they had more information. One of the mirror neuron regions, the inferior parietal lobe, was active while identifying the emotions in the story. And scores on a test of empathy were related to how active that region got when they had to make an inference about the dad who was still in the dark. Not all studies show this, though. In fact, many do not. So then again, most studies in this area have small sample sizes, so there's a chance that there are real relationships between these neurons and empathy that aren't being detected. And just to make things more complicated, these studies are all correlational. They can say that there's a relationship, but they can't directly infer causality, which means in the end, we don't know if these brain regions are necessary for empathy or if they just happen to light up when we're experiencing it for some unrelated reason. Like with so many things, especially in brain science, we need...
Sorry, I paused it a little early, but it basically says we need more research here. So, yep, that is the case. We need more research there. Hopefully you got a little bit excited about neurons, though. That's one of the main purposes of that video, to show you essentially what is possible. So maybe next time I will watch the video a little sped up, but it's hard to see reactions from students in the class if I'm going too fast or too slow. So I haven't decided if I'm going to speed up videos. But hopefully that gets you a little excited about neurons and what their possibilities are. So our neurons can do amazing things like learn from specific actions. So this is a artist rendering of a neuron, definitely not to scale either. So although some neurons are as long as a meter in humans and a couple meters in giraffes, actually. So the nervous system is actually the body's entire electrochemical circuitry. So most of what we focus on in psychology, and this class specifically, is the brain itself. So the brain includes things like billions of cells, billions of neurons, these brain cells, but also the nerves. The nerves are also neurons, so sensory and motor neurons. So the nerves that get the sense that you're getting pinched or burned, and motor nerves that are telling your muscles to move, your spinal cord, as well as your endocrine system and your hormones. So things like your organs release different hormones, well, not all of them. Some of your organs release hormones that are tied in with this, with the other nerves in your body. So this entire system is all the nervous system, and it all has an impact. So one of the biggest things about the nervous system is plasticity, that in large part, most aspects of the nervous system, especially neurons themselves, are capable of change and modification over time. So most of this is done through the physical process of the connections between neurons, strengthening, changing, connecting to different places. So does anybody remember from the reading, if you've gone through chapter 2, does anybody remember the story of the taxi drivers in London and what they found about them? Yeah, they had the city streets memorized. And do you remember the differences within their brains? So when these taxi drivers were compared to people who didn't have the city streets memorized, what was different about their brains? So sorry if someone's typing this and I'm going to just answer it right now to keep moving on. But one of the biggest things is these taxi drivers who had memorized all these city streets, there were specific parts of their brain that was more dense and had more activity. So their brain was literally thicker in specific areas and had more activity than someone who didn't have such a big mental map of a city. So there was a physical change to their brain, to their neurons, because of this skill that they had developed. And that's an example of plasticity. This wasn't something that they were born with. They didn't just have this area of their brain bigger from birth, they develop this by learning the streets, by having those memorized. I wonder if it's the same for a lot of Uber and Lyft drivers as well. So with that, the brain does a lot of work. The brain is integrating things like sight, sound, touch, temperature, taste, smell, messages from your organs. It's where we think, it's where we plan. So it integrates our past experiences, our memories to make meaningful connections now. Like we learned from the study on mirror neurons, it's looking at and observing and learning from just watching people. And so from doing that, it can learn new skills. So let's break down the nerve and the nervous system in a little more specific detail. And we'll probably just get through the structure of neurons before the end of class. So afferent nerves, they're also called sensory nerves. They essentially carry information into the brain. So you've got, say, skin, and there are cells, specific neurons that get messages of pressure on your skin. There's specific neurons that get messages of heat on your skin. And so it will get that message that there's been pressure, that there's been heat, and that afferent nerve will then send that message to the spinal cord, which will connect with other neurons over here at a synapse and send that up to your brain. Or in some cases, if there's a really big pain or burn, it might go directly back to an efferent nerve that will go to a muscle. So efferent nerves carry information out to the limbs. So whether you choose to, say, grab a monkey bar at a playground, or if you've just been burned by a soap and you instinctively pull your hand back, that message to move is coming through these efferent nerves. And that efferent nerve is connected to the muscle at different places to tell that muscle to constrict and use its energy. So the central nervous system is this whole area, the spinal cord, the brain, which includes the hindbrain, the midbrain, and the forebrain. So the hindbrain is this thing basically at the bottom and the back of the brain, closest connected to the spinal cord. The midbrain is kind of the middle area inside, so the very center of your brain from all direction. And the forebrain is the kind of outer area. And each of these systems has a specific job. There's some more resources in the slides if you want to learn a lot more about the divisions of the nervous system. We'll learn a few, but not too much. I want to focus more on neurons themselves right now. So there are many, many specialized neurons, like those that sense pressure or sense heat or talk specifically to muscle cells, but they all share these same basic common characteristics. They have a cell body, so this big area where things like its mitochondria are, where the nucleus is. They have an axon, and they all have a single axon. So this is the highway of information out of a neuron. They have multiple dendrites. I mean, it could have 1 to a couple thousand dendrites, and this is how messages come in to the neuron. And they have a myelin sheath, which is this kind of pinky orange stuff. It's essentially it's also a cell itself, but it's essentially a fatty insulation around the axon. And so that speeds up the process of sending a message out of the neuron. So dendrites is where the messages come into the neuron. A message can also touch the cell body of a neuron and come in that way too. And then the axon is where the neuron sends messages out. There can be many of these axon branches. So it has one major highway of information out, but then you could say this is a lot of exits. I guess you could think of it that way. But it's all coming from this one axon. There can be, again, thousands of dendrites attached to or growing out of a neuron. So cell body directs the growth and maintenance of the cells. Similar to any other cell, this is where the processes are working to keep this specific cell alive. So this neuron might be in your brain and it's trying to stay alive. So it's using energy, it's using sugar, vitamins, minerals, those kinds of things. In humans, an axon. The longest ones we have are 3 feet that are going all the way down our spinal cord. For giraffes, also, they have some axons in their spinal cords that are many meters long, which is pretty impressive. Dendrites bring that information in. And then that myelin sheath is these fat cells that insulate the axons. All right, with the time we have, I think the last thing we'll do is watch this little video about a human stem cell specializing into a neuron. And then we'll talk about how neurons communicate with other neurons and how the brain in general is structured. I think this is really impressive. It's a human stem cell specializing into a neuron, and that whole process takes about 14 hours total. So let me get to the right one. This page has a lot of different videos on it related to neurons. Let's watch this one specifically. I don't think I'll play the music. It's just really loud in my ear. I think I got the wrong one, or I wanted to go a little further. Oh, yep, this is the right one. The audio is incredibly loud in my ear. It's just a instrumental track, not really relevant. They're not saying anything about it. The words on this are more important. Of course, I paused it and replayed it, and that made it die. So we'll start our next class with that video. I'll have it all prepped and ready to go, so we can watch how a stem cell will specialize into a neuron. The main process of it getting from that stem cell into a neuron is pretty impressive to watch it, going from that kind of little blobby thing to this little spindly looking neuron. It's pretty impressive. So, but with that, I think that'll be the end of class today. I will let you go, and we will continue on talking about the neuron and the brain and how it connects with other neurons the next time we meet. Don't forget, there is the Canvas shutdown this weekend, so make sure you get any work in before the deadline, as well as any disability services accommodations to me. Other than that, have a great week, and I hope you have a great Labor Day weekend as well.